Let us discuss the histology of the thyroid gland. On the surface there is a fibrous capsule. Inside we can find spherical or ellipsoidal objects called thyroid follicles. These cavities have various size on a histological section. So these are thyroid follicles. The thyroid follicles are lined with one layer of cuboidal epithelium. And sometimes there are very rare cells called parafollicular cells. So first, these are follicular cells. They have a shape of a simple cuboidal. Epithelium. However, they might also occur as nearly flat cells. This is the normal appearance, cuboidal cells, and sometimes they might be even low columnar with microvilli. This is resting, this is normal, and this is under activation by thyroid stimulating hormone of the adenohypophysis. But normally let us consider the cuboidal shape. And there are also special cells here on the same basal membrane that are very clear, and they are called parafollicular cells. Or C cells. C like clear. Okay, first to the activity of follicular cells. Inside we can find a substance called thyroglobulin. Also known as the colloid. And among the follicles there is loose interstitial connective tissue with many capillaries. That are collecting the hormones. So this is interstitial connective tissue with capillaries. Let's have a detailed view on one of these follicular cells on extra scheme. If this would be the basal membrane, here would be the cuboidal follicular cell. So first we have the capillaries here below the basal membrane, lined with endothelium. The follicular cells are able to accumulate iodine anions and to make a molecular iodine and to release it into the thyroglobulin. The thyroglobulin is a reserve substance with high molecular weight. It's a polymer that undergoes iodation. Its amino acids are attacked by this iodine, and the precursors of thyroid hormones are formed here. Once they are ready, by the way, the thyroglobulin is also produced by the follicular cells. So once the products are ready, they are taken back by a process called pinocytosis. You might call it cell drinking, and this thyroglobulin is decomposed into the hormones of the thyroid gland, which are known as a triiodothyronine or tetraiodothyronine. T3 or T4 tetraiodothyronine. That tetraiodothyronine is also known as the thyroxine. And these T3 and T4 hormones are released into the bloodstream. Now, most of these steps are strongly promoted by the thyroid stimulating hormone of the adenohypophysis. This might result into various microscopic forms of this follicular epithelium. So upon low activation, the epithelium is more or less resting. It's low cuboidal or even flat. And the histological picture of the low activity looks like this. Plenty of thyroglobulin. And it's the response of the low activation by TSH. However, if in the opposite, the thyroid gland is overstimulated, the epithelium is very tall, it's even columnar, there are only small amounts of thyroglobulin because the thyroglobulin is produced and instantaneously it's decomposed and released into these T3 and T4 hormones, and this is the histological picture of a significant stimulation of follicular cells by the TSH. Let's go back to the parafollicular cells for a second. They have very clear cytoplasm. And these are individual cells scattered in the follicles. They are above the same basal membrane but not in direct contact with the thyroglobulin, and also the embryonic origin is completely different. They are infiltrating the thyroid gland during the embryogenesis, and they are producing a hormone called calcitonin, which, using various mechanisms, is lowering the calcemia in the blood plasma.